Hey, it's Dr. J. Today we're doing 2.4, multiples and factors. Throughout this course and probably any math class you'll take from this point on, we often, just casually mention, though this is a multiple of that or this is a factor of that. And, for somebody that's well versed in this and you've had a lot of experience in this, you might look at a number and go, oh yeah, clearly that's a multiple of this or that or the other. That's a multiple of 5 or that's a multiple of 3 or yes, of course 7 is a factor of this or 63 or something. And it sort of seems as if, there's like, how do they know that? How do you know that so quickly? Or I often will get, emails from students that will say, Dr. Jordan, I can solve the equation. I don't have any problem solving the equation, but whenever we do these, extensive word problems and things where you're using this terminology, I don't know how you got that. I don't know how you got that so quickly. And sometimes, when we're back in the classroom, I would say, I would look at it and say, you're working too hard. You sit there and try every single number, especially when later on we're going to get to this process called factoring. And some students will look at me like, how did you know that so quickly? Well, how did I know that so quickly? Because we study multiples and factors extensively to the point where we don't really have to think about it too much anymore. I mean, occasionally you have to stop and think, but you really want to get to the point where you just can look at it and then you can answer, whether or not something is a multiple or a factor. So that is the goal of this lesson today. We are backing up a little bit. I'm not going to be solving equations. I'm not going to be evaluating expressions and things like that. I'm just going to be talking about the terminology behind multiples and factors. Okay? Let's start off with multiples. So here's the definition. A number is a multiple of n if it is the product of n and a natural number, also known as a counting number. All right, so that's the definition of a multiple. I know it seems kind of obvious, right? It comes from the word multiply, yeah? Product, multiple, multiply. My glasses are getting a little smudgy. Probably the easiest example is the multiples of 2. Yeah, multiples of 2. So again, in this definition, when I say n in this case is 2. Okay. So the multiples of 2, we take the counting numbers. Yeah, counting numbers, also known as the natural numbers. All right. And if we have the product of n and a natural or counting number, we could just take all of the counting numbers and multiply them all by 2. Yeah. Multiply them all by 2. And we get, what do we get? 2, 4, 6, 8, 10, 12, 14, etc., etc., etc. So these numbers are all multiples of 2. Yeah. These are going to be the easiest ones. These are going to be the ones that you never, ever have to think about. Multiples of 2 have a special name. We just call them even. Yeah, so every time you see an even number, you automatically know it's a multiple of 2. Now, they get a little tougher as we go along. These are the ones that you don't really even have to think about. The rest of them get a little trickier. I can't just say, if the next one are just odd numbers or something like that, but it's not that easy. They get tougher. So let's go to multiples of 3. Yeah. So again, we take the counting numbers, or the natural numbers. I like to say natural. 1, 2, 3, 4, 5, 6, 7, etc., etc., etc. All right, and we're going to multiply them all by 3. I'm going to get tired of drawing these arrows every time, so we're just going to do it. So we get 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5, 3 times 6, and 3 times 7, etc., etc., etc. So these are all the multiples of 3. 3, 6, 9, 12, 15, 18, 21, etc. Notice that they're not all odd. Very important observation. So sometimes people think, oh, if it's a multiple of 2, it's even. So if it's a multiple of 3, it's odd. Well, that's not true. 6 is not odd. 12 is not odd. 15 is not odd. Sorry, 15 is odd. I'm pointing to the wrong one. 18 is not odd, yeah. The next one after 21 would be 24. 24 is not odd, and so on and so forth. However, there is a neat fact about multiples of 3. If you add the digits, you always get a multiple of 3. So, you take a number like 15, yeah? Is 15 divisible by 3? We'll add the digits, 1 plus 5, right? And you're going to get 6. Yeah? 6 is just another multiple of 3. Yeah. How about a number like 24? 2 plus 4. You get 6 again. Yeah. You can even take a big number like, this works really good for big numbers. Yeah. So suppose I have, 3,108. Yeah. Is 3,108 a multiple of 3? Well, we could use this fact. If you add the digits, you always should get a nice multiple of 3. So let's add these up. 3 plus 1 plus 0 plus 8. Yeah. 3 plus 1 is 4. Plus 0 is still 4. Plus 8 is 12. Check. Look. 12 is a nice multiple of 3. Yeah. You usually get a nice, easy one that you can see clearly. It's usually 6, or maybe it's 9, or it's 12, or one of the ones that you really know from elementary school. You're not going to get, 755 as the final answer here. You're always going to get a nice multiple of 3 that you can memorize in your head. Okay? So that's the test for understanding multiples of 3. Multiples of 4. Oh, there goes my camera again. Come on back to me. All right, well, let's just go ahead and give it a second. Natural numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, etc., etc. It's not that bad, is it? It's pretty bad, yeah. There we go. So we take the natural numbers and we're going to multiply them all by 4. Yeah. And we're going to get 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5, 4 times 6, 4 times 7, 4 times 8, 4 times 9, 36, etc., etc., etc. So these are the multiples of 4. Okay. Now here's what I would do for 4. All right, 4 has a neat trick. Or let me call it a technique. A trick makes it sound like magic. Technique is math, yeah? So the technique for a big number, to determine if it is a multiple of 4, look at the last 2 digits. So you don't have to add anything up. You just look at the last 2 digits. If the last 2 digits is one of these numbers, then so is the entire number. All right. Now you probably want to memorize a little bit more than 36. So let's go 36. The next one would be 40, then 44, then 48, 52. Notice you're just counting by 4s. 56, 60, 64, 68, 72, 76. I better go a little bit more. 80, 84, 88, 92, 96, and then 100. Oh, you don't need to know 100. You could stop at 96. All right. Although I guess you should know 100 is divisible by 4, but I think you already know that because 100 divided by 4 is 25, so you already know that. So if I have a big number, you know, something like, I don't know, 2,918, yeah? Look at the last 2 digits, yeah? So this is not a multiple of 4. And notice it's not here. 18 is not here, so neither is not either, or I could just say neither. Yeah, that's what not either really means, right? Neither. Or some people say neither. All right. Let's do another one. So how about a big number like, I don't know, 32,828? Is that a multiple of 4? Well, I don't know. Look at the last 2 digits. Yeah, last 2 digits. This is a multiple of 4. Yeah, so is 32,828. So 32,828 is a multiple of 4. 2,918 is not a multiple of 4. All right. I have to admit this sort of introduction is kind of boring, but these techniques that I'm giving you, make sure that you write these down or that you memorize these so that for the rest of the semester and hopefully for the rest of your mathematical life, you just know this stuff, right? It takes time, it takes practice. I have to admit, occasionally I'll forget one of these tricks and I'll have to go, oh, what was that trick again? I'll have to remind myself of what it is. Nothing lasts forever. Everything's temporary, right? So how about this? Multiples of 5. So again, we take the natural numbers, 3, 4, 5, 6, 7, 8, 9, 10, etc., and multiply them all by 5. All right, so what are we going to get? 5, 10, 15, 20, 25, 30. You probably memorized this when you were like 6. right? 35, 40, 45, 50, etc., etc., etc. So these are the multiples of 5. This one has a really easy way to recognize or to know if a number is a multiple of 5. Very easy way to know. Look. Notice something? The last digit is either 0 or 5. I tell you what, if you live to be 90, you live to be 100 years old, you will never forget that. A number is a multiple of 5 if the last digit is 0 or 5. Enough said. Yeah, I don't have to say anything more about that. You think I'm going to do every number? I'm not. I'm going to do the ones that I think are really important. Okay. 6 is kind of important. So again, take the natural numbers, etc., etc., and multiply them all by 6. So you're going to get 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. So these are your multiples of 6. Now there's not an easy trick for knowing the multiples of 6. The technique is a multiple of 6. A number is a multiple of 6. I'm going to say mult of 6. If it is even, so notice they're all even. Look, 6, 12, 18, 24, 30, 36, 42, 48, 54, and 60, and a multiple of 3. So we don't actually memorize the rule for 6 independently. It's not its own rule. It's a combination of the first rule, the even rule. So to be a multiple of 6, you must be even. Notice these are all even. And they're all multiples of 3. So remember the trick, 54, for example. 54 is even. And 5 plus 4 is 9. So it's a multiple of 3. So 54 is both even, and if you add the digits, 54, you get a multiple of 3. All right. We'll come back to this one later in the lecture. I really just want you to memorize what it means to be even and what it means to be a multiple of 3. If you memorize those two, you get it for free. Multiples of 7. Something is a multiple of 7. The rule is too complicated. Yeah, it's so complicated that it's not even worth it, right? Multiples of 7. They're all over the place. So notice if you multiply all of these numbers by 7, you get 7, 14, 21, 28, 35, 42, 49, etc., etc. There really is no easy way. You just have to do it. So if you want to know whether something is a multiple of 7, just do it and see if it's a multiple of 7. Multiply it, or you could divide as well. We're going to get into division later in this lesson. So in other words, I'm not teaching you a trick for 7. There is no nice way. All right. Also for 8, we look at the last 3 digits. Yeah, but that also is hard. Yeah, because, okay, great, you got this number, right? You got, 5,942, right? Okay, so the trick is, look at the last 3 digits. Well, that doesn't help, yeah? So it doesn't really help. I mean, do you know whether 942 is divisible by 8? Right? Well, I don't know. If it's a multiple of 8, you could just sit here and multiply until you get 942. All right. So in other words, I'm saying for 7 and for 8, it's not even worth having a trick. All right. In other words, if you were to walk up to me and say, Dr. Jordan, is this a multiple of 8? I would go, I don't know. I would just have to do it. Same thing with 7. All right. So sometimes there is no easier, softer way. The only way is just to actually do it. Hopefully you don't have to resort to a calculator, but if the numbers get really big, that's why we have calculators. 9 has a cool trick. Multiples of 9, it's the same rule as 3. Yeah. So again, let's go ahead and look at the multiples of 9. So let's multiply all of these guys by 9. I'm not going to draw all these arrows, but you're going to multiply by 9, right? So 9 times 1, 9 times 2, 9 times 3, 9 times 4, 9 times 5, 9 times 6, 9 times 7, 9 times 8, 9 times 9. Yeah, and then 9 times 10. So here's your multiples of 9 up to 90. Obviously, they keep going. All right. It's the same rule as 3. All right. If you add the digits, you always get a multiple of 9. So when I say the same rule as 3, I mean the same rule but applied to 9. Yeah. So just grab one of these offhand. 54. 5 plus 4 is 9. Yeah. A multiple of 9. Yeah. 9 is a multiple of 9. 9 times 1. Yeah. Grab another one. 81. 8 plus 1. Yeah, it's 9. For a large number, for a big number, say 4,192. All right, add up all the digits. 4 plus 1 plus 9 plus 2. You're going to get 16. 16 is not a multiple of 9. So neither is this. Okay. Let's take one that is. 6,327. Take one that is. So add them up. 6 plus 3 plus 2 plus 7. 6 plus 3 is 9, plus 2 is 11, plus 7 is 18. 18 is a multiple of 9. Multiple of 9. So is 6,327. Yeah. So if the number you start with, when you add up all the digits, you get a number that's already a multiple of 9, and these are the ones that you should just memorize, typically up to 90, or you could go one more, 99. 99 is a multiple of 9 as well. Once it gets into the hundreds and the thousands, nobody bothers memorizing. I shouldn't say nobody. There's probably somebody out there that memorizes them. But most, adults know their numbers, memorize their numbers, multiples up to about 100. About. I mean, some people go a little bit further. I make my kids go to 200. I'm mean. All right, and we're going to stop with multiples of 10. I'm sure you're all screaming at your computer right now, no, don't do it. Don't do it. Multiples of 10 are easy, right? These are the easiest one. Yeah, multiples of 10, right? Take the natural numbers. You probably love this. My favorite lesson in elementary math was the multiples of 10, right? These are the easiest. Come on back to me. What happens when you multiply a number by 10? All you do is add a 0. Yeah. I don't know about you, but when I was little and I got the multiplication test they give you when you're little, I would always do my 10s very easily, very quickly as I possibly could, because all you have to do is add a 0. So multiples of 10, the rule is they always end in a 0. Yeah. If the last digit is a 0, then it's automatically a multiple of 10. So those are, I would say I started and I ended with the easiest two rules. Even numbers, yeah, those are the easiest to recognize because the last number is always an even number, yeah, multiple of 2. And multiples of 10. All the ones in between, take it or leave it. I mean, I hope you learn the rules. I hope you memorize them. If you do memorize them, you will simply suffer less throughout the course. And if you don't memorize them, it doesn't mean you're going to fail. It just means it's going to hurt more. You're going to suffer when other people are, getting it just quickly like that. All right, so I'll leave it to you to decide. Suffer or not suffer. It's up to you. Choose your own adventure. Okay, so that is the lesson on multiples. Let's do a few problems to sort of see if we can remember these techniques. And then after we do a few examples, we'll move on to factoring. All right, so, I guess you could have called all those examples, but let's go ahead and do some actual problems. So I'm going to give you a bunch of numbers. Which ones are multiples of 2? I'll give you a bunch of numbers. Let's see. All right. Now, just to make this go a little bit faster, I know that you're sitting there watching this on your phone or watching this on your laptop. I'm not going to actually solve any of these problems like a calculation. I'm not going to do any calculations. I'm just going to remind you of the mental math of how to do this. So again, multiples of 2 mean that they are even. Yeah? So we just look at the last digit. No. Yes. Yes, that's even. Look at the last digit. And no, that's not even. So to tell whether something's a multiple of 2, just look at the last digit. If the last digit is even, then that means it's a multiple of 2. It's an even number. So which of these numbers are multiples of 3? Sorry, my brain is, there we go. No. There we go. I think I'm blocking the view a little bit. There we go. That's the number I'm looking for. Okay. So multiples of 3, you can either do it mentally or you can write it down. Let's try it both ways, okay? 47. All right. 47. All right, mentally, 4 plus 7 is 11. 11 is not a multiple of 3, so no. Yeah. And again, if you want to write it down, 4 plus 7 is 11, not a multiple of 3. So if 11 is not a multiple of 3, neither is 47. All right, 1 plus 2 plus 3, that's 6. 6 is definitely a multiple of 3, so yes. Here, I'll just put a check for yes. Check that one. Yeah, 1 plus 2 plus 3 is 6, yes. Multiple of 3. Now see if we can do this in our head. 5 plus 9 is 14. Plus 7 is 21. Plus 2 is 23. So no. 5 plus 9 plus 7 plus 2 is 23. No. Yeah, 23 is not a multiple of 3. Just because it ends in a 3 doesn't mean it's a multiple of 3. None of those numbers were multiples of 3. 23 was not in any of those numbers. All right, this is the one I was sort of struggling with. Just to make sure I wrote it down correctly. You know, I made that mistake before. 4 plus 0 is 0. 4 plus 0 is 4. Plus 2 is 6. Plus 8 is 14. Plus 4 is 18. So yes, that one's a multiple of 3. Let me double check that. 4 plus 0 plus 2 is 6. 14 plus another 4 is 18. Yep, that's 8. Multiple of 3. So these are the two multiples of 3. In the interest of time, just to save a little bit of time, let's just skip to 5. If you want to do multiples of 4, you can do them on your own. I think the next most important one is 5. I'm not even going to do any math on this one. Multiples of 5, the last digit is 0 or 5. So just look at the last digit and just say yes or no. Yes, no, yes, no. So these are your two multiples of 5. We'll go ahead and skip 6. Let's go ahead and skip 7. Let's go ahead and skip 8. And again, I'm not skipping them because they're not important. It's just, it's not worth the amount of time that it would take to do it. If I gave you one of those problems and you wanted to know, they're really, I mean, just do it. Just work it out and tell me yes or no. There's no quick trick for those. So if there is one, it's just not worth it. The trick is not any faster than just simply doing the math. All right, let's see. Let's go to 9. So 4,032, 531, 929, and 24,784. All right. So this one, you're going to add up all the digits. and see if that's a multiple of 9. So 4 plus 3 plus 4 plus 0 plus 3 plus 2 is 9. Check, yes. So that one's a multiple of 9. 5 plus 3 plus 1. Hey, that's 9 again. Check, check, yes, that's a multiple of 9. 929. 9 plus 2 plus 9 is 20. No. So that's a no, not a multiple of 9. Notice that it ends in a 9. That doesn't matter. It doesn't matter. It's a 9. You have to add them all up and see if the final result is a multiple of 9. Let's try this one. 2 plus 4 plus 7. You can do this mentally if you're good at mental math. When the numbers start to get this many, I just do it. I write it all out. 2 plus 4 is 6. Plus 7 is, what's that, 13. Plus 8 is 21. Plus 4 is 25. No, that's a no. Okay. So again, ideally, you know, I would like you to know all the tricks. I would say the most important ones are the 2, the 3, right? 2 and 3, you should definitely know those ones. 5 is so easy that if you don't know it, you know, I can't really help you. I think you know that. 9, remember 9 is the same trick as 3, okay? And then for 10, I mean, come on. A number is a multiple of 10 if the last number is 0. I'm not even going to do an example of that right now. Maybe I'll do one later, but we'll see. Okay. Now the next thing we're going to do is combine these rules together and have, you know, conditions. So example 5. Which of the following are multiples of 2 and 3? There we go. Okay, now I just want to remind you before I do this problem, a multiple of 2 and 3 also means it's a multiple of 6. All right, so if I say multiple of 2 and 3, I'm really just saying it's a multiple of 6, okay? All right, I don't know if you can see that. Yeah, there we go. Make sure you can see everybody. All right, first thing we should do. Remember, to be a multiple of 2, you have to be even. So any of these numbers that are not even, I can just cross them out right now. They don't even deserve to get the test, right? If you're not even, you don't even get into the game. You definitely can't take the test. Yeah? So the only ones we're going to consider are the ones that have potential, the ones that are even. So 32 is even. So this is a candidate. I don't want to circle it yet. So 32, 3 plus 2 is 5. No, 5 is definitely not a multiple of 3. All right, 888, 888. 8 plus 8 plus 8 is 24. Yes. 24 is definitely a multiple of 3. Yep. Okay. And then this last one here, 5 plus 6 plus 3 plus 4. Let's see, 5 and 6 is 11. 11 and 3 is 14. 14 and 4 is 18. Yes. So that one is also a multiple of 3. Oh, it's a multiple of 3 and 2. So that means this number is divisible by 6. Yeah, it's a multiple of 6. Okay. You might have noticed as I'm talking about multiples, I keep saying divisible by. Yeah. So note, very important note on terminology. You know what a big fan I am of vocabulary and you saying the numbers right. If m is a multiple of n, then we say m is divisible by n. Yeah. So for example, I don't know, what's one that we did? Let's see, let me just pick one out here that we did. $23,894. Yeah, let's see. Let's check it. Let's see. 2 plus 3 is 5. 5 plus 8 is 13. 13 plus 9 is 22. 22 plus 4 is 26. So no, it's not divisible by 3, but it is even. So it is divisible, is a multiple of 2, because it's even. I was hoping it'd be multiple of 3. So we say it is divisible by 2. Yeah. Maybe let's try another one. 1032 is a multiple of 3. If you don't believe me, do it. 1 plus 0 is 1, plus 3 is 4, plus 2 is 6. 6 is a multiple of 3. Well, then so is that. Yeah. So that means that 1032 is divisible by 3. So I often use those words interchangeably. Sometimes I will say it's a multiple of this, and other times I'll say it's divisible by this. It really means the same thing. All right, since 1032 is also even, it is divisible by 2. Hence, 1032 is divisible by 6. Yeah? If a number is divisible by 3 and it's also divisible by 2, it's divisible by both 3 and 2, that means it's divisible by 6. Okay. Should we do one more? I don't know what we're up to. I might have already done this one, but determine which numbers are divisible by 3, 5, 2, 3, and 5, sorry. I was trying not to duplicate a number there. So 2, 3, and 5 must be divisible by all of them. So let's use a little bit of deductive reasoning. Okay. Which ones are divisible by 2? They have to be even. So any one of these that are odd, boom, it's odd. So it's not even. So that one's out of it. What else? Is this one even? Even. Oh, this one's odd also. Odd also. Yeah. Okay. Let's go to 5. Let's skip the 3 for now. We'll skip that. We'll go to 5. Let's do the easy ones first. To be a divisible by 5, it must end in a 5 or a 0. Yeah, this doesn't end in a 5 or a 0. So no. Yeah, it doesn't end in a 5 or a 0. So we've really only got one candidate. Yeah, you could just pick it. Yeah, that must be it, right? But we should still check the remaining candidates. Now, I guess on your homework, you could just pick it, and if it's wrong, then go back and pick it again. You get as many times as you want. But on the quiz or on the test, you're not going to get multiple attempts, so you might as well know how to do it. All right, so let's check the remaining candidates. We only have one remaining candidate. I guess I probably could have squeezed one in here. Yeah. So we're going to go 2 plus 3 plus 5 plus 2 plus 0, 2, 3, 5, 2, 0. You actually don't need the 0. 5 and 5 is 10 plus 2 is 12. Check. Yes. That's divisible by 3. So this is the only number in this list that was divisible by all of the 2, 3, and 5. Okay. And again, if I ask you for a 10, obviously it would have to end in a 0. Yeah. All right. I think we're done with multiples and divisibility. Yeah. We're never really done. I don't want you to think we're done. We're just done for now in this lesson. Next, we're going to talk about factors. Here's the definition. If A times B, I'm using the dot for product, is equal to M, then A and B are called the factors, or just simply factors of M. We say M is the product of its factors. So M is the product of A and B. A and B are called the factors. You might be catching on here. This is directly related to multiples, right? Exactly. That's why we just spent almost an hour talking about multiples, or why I spent an hour talking about multiples. Because in order to find factors, you have to first understand multiples. Okay? Let's do an example. And let me actually make a note. 1 is a factor of every whole number, or every natural number, I should say. We're not counting 0 today, so we're just talking about natural counting numbers, the caveman numbers. So when I ask for a factor of something, 1 is an automatic free answer. List all of the factors of 96. List all the factors of 96. In other words, every number that is a product of another number, so factors, they usually come in pairs, that equal 96. So one way to do it is to get the free answer. 1 times 96. Yeah. This is sometimes called a factor tree. Now I'm just going to do a little bunch of mini trees. I'm not going to draw a big giant factor tree. I'm just going to do a little one. So now let's do divisibility. Let's talk about divisibility. Is 96 divisible by 2? Always start, so this is the free answer. That's your free one. And then start with 2. Is it divisible by 2? Yeah. 96 goes into 2 48 times. Yeah. So this is A and this is B. And this is M. Yeah. So when we make our tree is like this. Yeah. M is the big number, and A and B are the factors. All right, and do as many of these as you can. Don't keep going with these. We'll get to that later. If you've done big factor trees, I like to call these mini trees. Yeah, it's just a little mini tree. M for mini. We'll be doing the big tree later. All right, if 2 works, let's try 3. Let's see if it's divisible by 3. 9 plus 6. 9 plus 6 is 15. 15 is divisible by 3. Yeah, so this must be divisible by 3. Now, if you're not very good at mental math, that's okay. You know, I wouldn't be in this business if everybody was good at mental math. Just use long division. We've already learned long division. If you really want to be lazy, you can use your calculator, but that will end up catching you in the end, because when we get on to the harder math, that's not going to help you. So 3 goes into 9 3 times, 3 goes into 6 2 times, and the remainder is 0. You have to get a 0 remainder, so that would be 32. All right, let's keep going. 2, 3, what's next? 4? Let's see if it's divisible by 4. All right. Now again, there was a trick for 4. The trick was to look at the last 2 digits, but this number is already 2 digits. That's the reason why the trick really isn't that good, right? It's not that great of a trick. So let's just go ahead and do it. Right? I mean, sometimes the trick is there is no trick. Right? The trick is you just have to do it. 4 goes into 9 2 times. 2 times 4 is 8. Subtract, bring down the 6. 4 goes into 16 4 times. Remainder 0. All right. When you're doing divisibility and factoring, you must always get a remainder of 0. So you get 4 times 24. All right, let's go to 5. And you're looking at me going, why are you trying 5? The last digit is not a 5. It's not a 0, so don't even try 5. All right. How about 6? Yeah. 2 worked, and 3 worked. And remember, if it's divisible by both 2 and 3, well, then it has to be divisible by 6. You might already know it. It's 16. 6 times 16. That's if you're really good at mental math. If you're not really good at mental math, then work it out. Yeah, 6, 96, 1. Bring down the 6. 6 goes into 36 6 times. Remainder 0. Check. Yeah. But if you're good at mental math, 6 times 16 is 36. All right. 7. You could try it. It doesn't work. Yeah. Remember, I don't really give you a trick for 7. The trick is just try it. 96 divided by 7. Those of you that were really good at your multiplication tables are going, no, I already know the 7s, right? Maybe you memorized your 7s. I don't know. Maybe you didn't. I don't know. I've got them. They come from all over the place. So 7 goes into 9 one time. 1 times 7 is 7. Subtract. Bring down the 6. 7 goes into 26 3 times. 3 times 7 is 21. Remainder 5. No. Remember, for something to be divisible, you have to get a 0 remainder. So 7 doesn't work. What about 8? Does 8 work? Yeah, well, 2 worked and 4 worked. So if 2 and 4 work, something tells me 8's probably going to work too. Right? Let's try 8. You already know it? What is it? 12? 8 times 12 is 96. You should know that from elementary school. 8 times 12 is 96. Yeah. If you don't know that, that's okay. 8 goes into 9 one time. 1 times 8 is 8. Subtract. 8 goes into 16 2 times. You get 12. Remainder 0. Remember what I say. Everything you ever needed to know, you knew it before you were 10 years old. Yeah, so it's time to get in touch with your inner 10-year-old. Oh, what else? 9. Should we try 9? Well, 3 worked. So maybe 9 works. Let's do the mental math. 9 plus 6 is 15. Is 15 a multiple of 9? No. I'm not even going to try 9. What about 10? Does 10 work? No, because it doesn't end in a 0. All right. 11. I didn't talk about a trick for 11. There is a trick for 11. It's just one of those tricks that's not really going to be useful here. It's definitely not divisible by 11. You probably memorized your 11s, right? 22, 33, 44, 55. So 11 is like a number that's a duplicate of 2 digits that are exactly the same. Although it gets a little more complicated when the numbers get bigger, and we'll talk about that later. All right, 12. Well, we've already got 12. Yeah. So we're done. All right, we're done. So we've got all the factors of 96. I want you to list them all out. Use commas. You can put them in any order you like, but I like to put them in sequential ascending order. Notice I'm going through and grabbing them all in order. If you like, you can just keep them paired up if you like. Just replace the dot with a comma. All right. I'm not. I'm going through in order. And I'll show you something neat about this when I'm done if you like neat patterns. So then 8, what's the next one after 8? Then 12, then 16, then 24, then 32, then 48, and finally 96. And so this does have a neat pattern. 1 and 96. Look. 1 and 96. Yeah. 2 and 48. 2 and 48. You do not have to draw these lines. These are just, if you like, mental patterns. 3 and 32. 3 and 32. 4 and 24. 4 and 24. 6 and 16. 6 and 16. Yeah. And then finally 8 and 12. There you go. So those are all the factors of 96. All right, I know these problems do take a little while. List all the factors of 390. All right. Now you can start with any number you like, right? But it's always, I think it's easier to start with 2. All right. So list all the factors of 390. So it's divisible by 2. That'd be 2. What's that? If you can't do that with mental math, I think it's 195. I'm just guessing, though. I did that mentally. If you're not good with mental math, then go ahead and write it all out. That bubble is not big enough. 390 divided by 2, you get 1. Bring down the 9. You get 9. 9 times 2 is 18. Bring down the 0. 2 goes into 10 5 times. 5 times 2 is 10. Remainder is 0. So there's your mental math for that one. If you can do it mentally, that's great. If you can't, that's okay also. That's what I'm here for, right? All right. So we did 2. Should we try 3? Let's see. 3 and 9 and 0, that's 12. 3 plus 9 plus 0 is 12. That's divisible by 3. So 390 is 3 times 120, I think. Oh, no, 130. I think you can do that one with mental math, right? 3 goes into 3 one time. 3 goes into 9 3 times. 3 goes into 0 0 times. 130. And if you have to, use the long division algorithm. All right. 4. Look at the last 2 digits. No. Last 2 digits are 90. 90 is not divisible by 4. Try it. Try to take 90 and break it into 4. It doesn't work. You end up with fractions and decimals, remainders. Yeah. 5. Yeah, 5, which is the whole reason why I didn't start with 10. Right? Because that will just blow out your 5. You won't even notice the 5. This is definitely divisible by 5. Yeah. I don't know if you can do that with mental math. Try it. 5 goes into 39 7 times. Remainder 4. So 40. 5 goes into 48 times. So you get 78. Probably wouldn't have guessed that. Let's do that with mental math. Or let's do that with non-mental math. 390 divided by 5. 5 goes into 39 7 times. 7 times 5 is 35. Remainder 4. Bring down the 0. 5 goes into 48 times. Again, remainder 0. Check. You get 78. All right. 6. Yeah, 6, because I got 2 and 3. 2 and 3. 2 and 3. So 6, I know it's going to be divisible by 6, 195. Let's see, 6 goes into 19 3 times. 3 times 6 is 18. Bring down the 5, 6. Oh! I'm dividing the wrong number. Sorry, I'm a human being. I was looking at the 195. Remember, my number is 390, not 195. I shouldn't even be looking at that. Put a bar right there. Don't look. Don't look. All right, so let's go here. 6 times 3 is, it goes in way more than 3 times, though, now. 6 goes into 39 6 times. 6 times 6 is 36. Subtract, bring down the 0. 6 goes into 35 times. So I've got 6 times 65. Okay. All right, 7. I mean, you could try it. Rarely ever does it work, but you know what? I shouldn't discourage you from trying, because there's numbers that you might think, oh, I would never think to try 7, and you try it and it actually works. So, now, by the way, all multiples of 7, well, let's just try it. 7, the trick for 7 is not easily rememberable. 7 goes into 39 5 times. 5 times 7 is 35. Remainder 4, bring down the 0. 7 goes into 40. Again, 5 times, 35. Remainder 5. Nope. You're supposed to get remainder 0. All right. Let's try 8. All right. Well, I think we didn't try 4. right? Because 4 didn't work. We already knew it didn't work because look, 2 times 195, 195 is odd now, so there's no way a 2 is going to work again. So 8's not going to work either. How about 9? Is 9 going to work? What's the trick for 9? Remember, it's the same trick for 3's, right? So just add them up. 3 plus 9 plus 0, that's 12. 12 is not a multiple of 9, so I'm not going to try 9. And I usually end with 10. So 10 definitely works. This will be your last one. 10 times 39. All right. And then you want to list all the factors. I like to put them in order. Remember, 1 is a free factor. Oh, shoot. Did I forget 1 last time? Oh, shit. In example 7, I should have started with 1 and ended with 96. I'm not sure if I did that, and I'm not going to stop the tape to find out. So always start your list with 1 and end your list with the number that you started with. So I'm going 1, 2, you can cross them off as you go if you like, 3, 5, 6, 10. What's next? 39, 65. You basically just go backwards. 78, 130, 195, and I should end my list with 390. Now the order does not matter. I will accept this list in any order, but I will find, and you will find, and we will find that if you put it in order, you're just more likely to get it right. Okay. And then again, look back at example 7. Make sure to start with 1 and end with 96. I think I did that, but I might have started with 2. I might have forgot the 1 and the 96. I don't know. I'm not going to rewind the tape right now. I'm trying to get this done. Okay. The last thing we're going to talk about is prime numbers. P is a prime number if its only factors are 1 and P. In other words, P is equal to 1 times P. And that's it. There's no other way to factor it other than 1 and P. Right. Note, 1 is not prime. All right. And 2 is the only even prime. So all primes, P, are greater than or equal to 2. So all prime numbers are greater than or equal to 2, and 2 is the only even prime. 2 is equal to 1 times 2. And I should mention that the order doesn't matter. Yeah. If I say A times B, That's the same thing as B times A. Yeah, and we're going to get more into that later in the algebra sections. Today we're just doing a lot of arithmetic. So we call this a prime number. It's probably a good idea to memorize the prime numbers. I wouldn't say memorize all the prime numbers, but you should memorize some of them. 2, 3, 5, 7, but not 9, because 9 is 3 times 3, which those are the factors. 10, no. 11, yes. 13 is prime. 15, no. 15 is 3 times 5. 17 is prime. 19 is prime. Lots of teenage primes, yeah. 21. 21's not prime, no. 21 is 3 times 7. 23 is prime. At this point, they're all going to be odd, right? 2 is the only prime that's even. 23, say 25, nope. 25 is 5 times 5. 27, nope. 27 is 3 times 9. 31, 31 is prime. 33, nope. 33 is 3 times 11. That's not prime. 35, nope. 35 is 7 times 5. That's not prime. 37 is prime. Okay. I don't know how many of these you want to memorize. I can do a few more. 39, nope. 39 is 3 times 13. So that's not prime. 41, 41 is prime. 43 is prime. Yeah. So these numbers, if you tried to factor them, they're not divisible by any other number except themselves in 1. Yeah. The only factors are themselves in 1. 45. 45 is 9 times 5, so that's not prime. 47 is prime. Yeah. How about 49? No. 49 is 7 times 7 is 49. How about 51? 51 looks prime, but it's not. Yeah. 51 is divisible by 3. 3 goes into 5. Look at 5 plus 1 is 6. So it's divisible by 3. 3 goes into 5 one time. 1 times 3 is 3. 5 minus 3 is 2. Bring down the 1. 3 times 3 goes into 21 7 times. So 51 is 3 times 17. So 51 is not prime. What's the next one? 53 is prime. Yeah. Etc., etc., etc. I don't expect you to memorize all the primes. I think knowing up to about 50, or 53 in this case, is good enough, certainly for this class. I would hope that as you go through your mathematics education, when you get into algebra and advanced algebra and maybe trigonometry, geometry, pre-calculus, calculus, I don't know where you're going, college level math of some sort. I know that every one of you need at least one college level math class to get your degree. So when you do get there, maybe your list of primes will grow with you, as you start to go more. I'm going to tell you honestly, I just walk around every day knowing this top line. These are the ones that I just know, when you're at the grocery store, you're driving down the street, or you're whatever. These other ones, you stop, you think about it. And as the list gets bigger and bigger, your brain slows down a little bit, and you have to start to think about whether or not the number is prime or not. I wish I could tell you a quickie trick that would tell you whether or not a number is prime or not. I can't. There is no trick. You just have to try it and see. All right, that's the trick. All right. Now, when a number is not prime, it's called composite. composite. It comes from the word compose, yeah? It is composed of A and B, yeah? Where A is not 1 and B is not 1. So if you can multiply two numbers, neither of which are 1, remember 1 doesn't count, then you say it's composite. This is a not equal to sign. Yeah? A is not 1, B is not 1. So if you can compose these two numbers together to get this bigger number, so the number M, this is M, is called composite. Sometimes I'll use N for number. In this case, I'm using M for number. See, I've got sort of two choices for number. And then I want to point out that 1 is neither prime nor composite. Okay. I guess that'll do it. I guess I could do one last example. If the number is prime or composite. Sorry. Takes me forever to make up my mind. Okay. All right, so let's just go through and determine if they're prime or composite. It's actually easier to find out if they're composite first, yeah? Because if a number is composite, well, then you know it's not prime. And vice versa. If it's prime, you know it's not composite. So it's easier to do this first. Find out if it's composite. All right. Oh, sorry, I wrote that funny. 245. 245 ends in a 5. So it's composite. Yeah. That's it. It's composite. I know it ends in a 5. It's a multiple of 5. Yeah. All right. 3,191. It's definitely not even. Yeah, so I know it's not even. All right, let's see if it's a multiple of 3. 3 plus 1 is 4. 4 plus 9 is 13. 13 plus 1 is 14. So it's not a multiple of 3. Yeah. What else? How about multiple of 4? No. Can't be a multiple of 4 because it's not even, right? It has to first be even to be a multiple of 4. How about 5? No, doesn't end in a 5 or a 0. How about 6? No, because to be a multiple of 6, you have to be even. And this is not even. How about 7? Well, just try it and see. You never know until you try, yeah? So 7 goes into 31 4 times. 4 times 7 is 28. Remainder 3. Bring down the 9. 7 goes into 39 5 times. 5 times 7 is, this is what I said earlier. There's no trick for 7. You just have to do it. 5 times 7 is 35. 39 minus 35 is 4. Bring down the 1. 7 goes into 41 again 5 times. Remainder 6, so no, 7 doesn't work either. How about 8? No, it's not even, right? Now, that's the cool thing about being odd. As soon as a number is odd, don't even bother trying 2, 4, 6, 8, 10. None of those numbers are going to work, all right? So I don't have to try 8. How about 9? Well, let's try 9. 3 plus 1 is 4, plus 9. I feel like I already did this. 13 plus 1 is 14. 14 is not a multiple of 9. Yeah, so it's not working. You could just Google it. Alexa, is 3,191 prime?
Yes.
Yes, it's prime.
3,191 is prime.
So if you get frustrated, just ask Alexa or ask Google, ask the Siri or something like that. It's prime. What I tried to do was try every number until I got frustrated. If you've tried every number up to about 10, it's probably prime. Probably, but I mean, 11 might work, 13 might work, 17 might work. I mean, you never know, right? So try every number that you can think of. At least try up to 10, all right, to get a good exercise. Otherwise, I'm wasting my time teaching you this lesson. All right. 203, right? It's not even. It's not divisible by 2. 2 plus 0 plus 3 is 5. It's not divisible by 3. It's definitely not divisible by 4. It's not divisible by 5. Right? It doesn't end in a 5 or a 0. It's not divisible by 6 because 2 and 3 we already tried. All right. And then worst case scenario, ask Alexa. Alexa, is 203 prime?
No, 203 is not prime.
So 203 must be divisible by 13? Alexa, what's 203 divided by 13?
203 divided by 13 is 15.6154.
Oh, it's not divisible by 13 either. So what is 203 divisible by? What is 203 divisible by? If it's not prime, I think it's 19? No? Alexa, what is 203 divisible by?
The integer divisors of 203 are 1, 7, 29.
7. There it is. The number that I didn't try was 7. 7 goes into 20 2 times. 2 times 7 is 14. Remainder 6. 7 goes into 63 9 times. 9 times 7 is 63. Remainder 0. What's that old saying? You always find it in the last place you look. I was about to say it was prime. All right, it's composite. 203. All right. How about 47? 47. We already saw that in our list. All right. We memorized all the primes up to about 50. 47 is prime. Yeah. Again, you could run through and try to figure it out and see if it's prime. Look at this one. 52,784. It ends in a 4. Composite. Yeah. And 682 ends in a 2. That's also composite. So that's about enough for this lesson. I've already gone on for over an hour, almost an hour and a half now. I hope that I've done a good job of explaining the terminology. We're by no means done with it. I mean, we're done with this lesson. This lesson's done. But the concepts in this lesson, the vocabulary in this lesson, the techniques in this lesson are going to last for the rest of your college career. And I mean, as long as you're in a math class, you're going to be needing these kinds of skills. So until we meet again, I will see you on the internet.